So let's talk about data structures. Often when you're programming, you're going to be doing something with data, whether that's manipulating, processing, retrieving, storing. Data is often the key property of a program. And there are many ways that you can store data when you're writing a program. You can store them in what are called primitives. These are your typical singular variables, things like integer, float, byte, char, sometimes string. You can also store them in arrays if you needed to group things together. And the native, for lack of a better term, primitive arrays tend to be pretty limited. You can't add elements to the end. You can't take elements away. You could create your own classes, and you can also create your own collections. Often what you find when you're doing programming, especially in web-related technologies, you'll be using a lot of primitives, and you'll be using a lot of collections. So when I say primitives, what do I mean? Well, they're simple singular values. You can think of it such as in Java or C# where you have int I equals 0. That means give me a variable that we'll call I and set it the value of 0. Similarly, if I had string name equals Kevin, that would be saying give me a variable called name of the data type string and set it equal to the value of Kevin. It's great for storing single pieces of data. Programs are very, very efficient at passing primitive data types around, of being able to reason about these primitive data types. But the problems are that they are singular. If you imagine that you were trying to store information about an employee or a student, right? You could have string first name, string last name, string job. And that'd be all well and good, but if you had multiple employees or multiple students and you needed to group those all together, you would run into a lot of difficulties around maintenance, around being able to reason about the material. So often you'll use primitives for one-offs that you don't really need to keep a lot of. Of course, the exception being within classes when they're member variables. But we're going to pretty much just push that off to the side for now and just talk about primitives out in the global scope or in the main scope. There are more complex data types. You can think of things like structures, right? Structures are groups of data. Usually, you'll create a structure out of combined primitives. So depending on the language, these may be classes. They may be actually called structures. They don't have behavior. Structures tend to just be data. So for example, if I had a structure for a person, maybe they have a piece of data called name set to Kevin, and a piece of data that's a string of job set to engineer. The nice thing about these structures is that they group data together for easier management. Right, so I can pass the person variable around rather than the name, a separate name and a separate job. It keeps them together for future use. While classes are built on top of structures. Whereas structures are concerned with data, classes tend to include behavior as well. What do I mean by behavior? I mean these methods and these routines. You can tell a class to do things. Some languages support one but not the other. One great example is that Golang doesn't have traditional classes, right? It has structures, and then you can define functions which can be attached to these structures. So beyond that, there's the concept of collections, and what I want to talk about right now are what are called dictionaries or maps, all right? In some languages, they're just plain objects. These tend to be key value pair data structures so that you can have, they're very similar to a structure, but they can be nested. They can tend to have different things on them like methods, especially in something like JavaScript where everything's an object. In Java, you'll see things like a map interface. So you see things like hash map. In C#, there'll be something like dictionary. In JavaScript, it's just a JSON object. They tend to be a little lighter than a traditional class object, primarily because they are designed to manipulate data in a very structured manner. So, for example, you'll have a key value pair, and the data is accessed via the key. So, for example, if in JavaScript, if I had a object called me, and I set the name property to Kevin, the job property to engineer, and colors as a subarray, you'll see that I can actually grab the data in and out of the object quite easily. I can add new values. For example, I can change the engineer value to geek, and I can add new keys as needed. So my dream job might be sleeper. Now, one thing to note is that depending on the language, you may or may not be able to add these additional values, these additional properties. But in something like JavaScript, it's very easy to just add a new property. And again, this is JavaScript. You'll see something different in Java and something different for C#. So the great thing about maps, especially things like hash maps, is that the internal storage tends to make it very quick for lookups. So if you know what the key is that you're looking for within the hash map, it's very easy to go through that hash map and grab that data out because it uses an internal hash, which also prevents duplicate keys. So if you try to set a value to a specific key, you'll replace the value rather than having two keys of the same name. However, if you have a really big hash map and you need to loop over all the data, it may not be the best approach, but in something like JavaScript, it's really your only choice. In something like C# or Java, you might want to use something more like a set or a list. So here's an example in Java. Probably the most common map implementation within Java is the hash map. And you'll see that in this example, we set a new hash map called map, and we say that the key is going to be a string and the value is going to be a string. Often the key will be a string or an integer, something that's very easy to decipher. And the value can be really anything. I could set that to an object, so that I can store strings, I can store integers, I can store array lists or other hash maps. But in this case, I just set two strings. So I say map.put. You'll see what I'm doing is I'm just saying, hey, for my new hash map, give me a key of name and set the value to Kevin. Give me a key of job and set the value to engineer. In C#, it's very, very similar. In fact, the only difference is just what these things are called. So, for example, you see dictionary as the class name, and you see that instead of put, it's add with a capital A. Otherwise, it works exactly the same. JavaScript, you're just going to use plain old objects. You'll sometimes hear them called POJOs. It's from the world of Java, where it's plain old Java object. Well, the web community kind of took that as plain old JavaScript objects as well. Again, remember arrays, a lot of the data structures just convert down to plain old JavaScript objects, JSON. So you'll see I declared a map. I added a key called name and a key called job. There's two different ways of putting that syntax in there for JavaScript. You can either use the dot notation or you can use the array notation, which is the second line there, where I set name to Kevin. Either one of those will work in JavaScript. So the whole concept here is that primitives and complex data types can be stored together. You can think of them as something like a list of names, where each name is different, but if we wanted to pass them around, we definitely wouldn't want separate variables. Now, imagine that instead of having these key value pair objects, that I just had a list of names, right? So I had a class of students, 35 some odd students, and all I wanted to do was get all of their names, and I put all their names into a data structure. Well, I could have an object like a hash map and say student 1 name, and then give them the name, student 2 name, give them the name. But that's not very efficient. Maps would not be helpful in that case. What I would want in that case is an array. And if you remember back, arrays are pretty straightforward lists of items. So you can store data in a row, and you can access each one individually. In many languages, they tend to be fixed length, and they have pretty limited search capability. For example, you have to loop over each element to find things. There's temporary storage involved, especially if you're trying to deduplicate anything. They tend to be pretty error prone. You have off by one errors. You have questions about how do you manipulate an array? What if you need to add a new element to the end after the array's been declared? What if you use the wrong data type? What if you declared it as int and all of a sudden you want to store a float? What you really want to use, and what you'll find that you'll use in a lot of environments instead, are lists or sets. Okay, they tend to be like an array on steroids. Often, most languages such as C# and Java, they're implemented as classes that fall into collections or generics. And lists can solve a lot of those problems. Now, they're not panaceas, they're not perfect, but they can solve a lot of those problems. Defaults can be added, but you don't need to know the size up front. So you can say, give me a new list, and then go through some code and be like, oh, I need to add 2 more elements to the end of it, and it's not a big deal. You can access the size of the list very easily. You can say that this list can only contain strings, or it can contain objects, or it can contain whatever. You can be a lot more flexible. And typically, most languages will provide a mechanism for sorting and deduplicating. So in Java, there's an interface called list, and one of the most common implementations of that interface is the ArrayList. If you see a declaration where you see a class name and then you have your greater than and less than sign with a T in the middle, that's just a generic. That T stands for a type. So you'll see in the example that I have ArrayList string. That's just saying that my ArrayList is going to contain all strings. So if you're going through documentation, you're going through tutorials, and you see that notation with the greater than and less than signs with a T, that's what that's referring to. It's just saying it's a generic type, and that's where we get the term generics from. So in this example, you'll see that I have an array list, and I didn't need to declare how big it was. I didn't say how many elements there were. I just added 2 values, Kevin and Mike, and that was that. I didn't have to worry about resizing. I could call sort on this list. I could call a lot of different methods on this list. So I have a lot more flexibility on top of what the standard array with the square brackets would give me in Java. In C#, we don't really use the array list. We use the list string, which is the same thing as the array list in Java. So you'll see that you've got list with the angle brackets and the type of string. You've got add Kevin, add Mike, just the same. JavaScript doesn't really use generics or collections, so you'll just use a standard array. The array prototype in JavaScript does provide a push method, so you can add things to the end of it. There's a couple different ways that you can go about it. One of the problems with JavaScript is that there's more than one way to do a lot of different programming techniques. So I'm just showing the common, and what I recommend using the push method.